Okay, today is learning about objective 11.6 ELR. It's finding the surface area and volume of a sphere. All right, let's talk about the parts of a sphere first. So we have the center here. We have the radius. We have the diameter, which is this whole thing. Hemisphere will be half of the sphere. And then they have something called the great circle. So here is a visual of what the great circle is. The great circle is when you have a plane intersecting the sphere through the center. This is called the great circle. It is basically the equator if we were thinking about the Earth. So there it is. That's a great circle. It's intersecting, a plane intersecting right through the center of the circle is called the great circle. All right, hypothetically, picture a baseball. If we take it apart, what would be the surface area of this ball? Well, think about it. Kind of looks like we have four circles, right? And what is the area for a circle? It is pi r squared. And how many do we have? We have 1, 2, 3, 4 of them. So the surface area for a sphere would be 4 times pi r squared. So here it is, official, 4 pi r squared. Go ahead and put that on your paper. And now let's do this example. Okay, so we have the Earth's equator, which is the radius. I'm plugging it into the surface area formula. There is the approximate surface area of the Earth. Okay, volume for a sphere. It is 4/3 times pi times radius cubed. Again, another formula to put on that piece of paper. So let's take a look at this one here. This time I'm giving you the volume as 5,000 meters squared. What is the surface area to the nearest square meter? All right, so surface area was 4 pi r squared. We're given the volume, and we know the volume formula is 4/3 pi r cubed. Let's plug in the volume, and we need to work backwards to try to get what r is. So how am I going to move all of this stuff away from the r cubed? Well, let's go ahead and get rid of the fraction first. I'm going to divide by 4/3 first. When I divide by 4/3, what happens to the 4/3? It actually flips around. So it becomes 3/4 times 5,000. I'm going to put it over 1 to equal pi r cubed. Once we do that, I get 3,750. Now I'm going to divide by pi on both sides. And I get it to be 1,193.7 is r cubed. Now, how do I get rid of something raised to the third power? When it was raised to the second power, I would do the square root. But since it's raised to the third power, I'm going to do something called the cube root. So that means what number multiplied by itself 3 times will give me that number underneath. There is a button on the calculator that you could use to get the cubed root. If you have the TI calculator, it's under the math button, which is number 4. And it looks like this. So I'm going to go down to number 4, press it. Now I'm going to put 1193.7 underneath the square root. And I get it to be about 10.6 is my radius. That's what I need now to plug in to get my surface area of this volume of this sphere. So now let's go ahead up to here and plug in that. So it's 4 times pi times 10.6 squared. Okay, when I plug it in and work it out, they went to the nearest square meter, so it's 1,412 meters squared. All right, last question. You have an ice cream vendor presses a sphere of yogurt into a cone. If the yogurt melts into the cone, will the cone overflow? So, we need to consider the volume of the cone compared to the volume of that ice cream on the top, the sphere, because it's going to melt inside the cone. All right, so I'm going to find the volume of the cone, and then I'm also going to find the volume of the sphere, which is the yogurt on the top. Okay, when I plug in all the information with the radius and the height on both sides, these are my two answers. Here's for the cone, here's for the sphere. So will the yogurt, will it overflow? Since the sphere volume is higher than the cone volume, it will overflow. Yes, it will overflow.